Okay, final part, part 6, 2 solving systems of linear inequalities. So we've got a story problem down below here. Charlene makes $10 per hour babysitting and $5 per hour gardening. She wants to make at least $80 a week, but can work no more than 12 hours a week. A, write a system of linear equations. So the first thing we want to do is identify our X and our Y. So we can call X our babysitting and Y our hours gardening. So let's write that off to the side. So X is our hours babysitting, and Y are hours gardening. And then before we forget, let's go ahead and put that on our X and Y axis here as well. So the X is our hours babysitting, and our Y are our hours gardening. Okay, so Charlene makes $10 per hour babysitting. Well, our hours for babysitting is called X. So 10X. And she makes $5 per hour gardening. So gardening is Y. So plus 5Y. She wants to make at least $80 a week. So is she going to be able to pay her bills if she makes $79 if she needs to make at least $80? The answer to that would be no. But could she pay her bills if she made exactly $80 a week? Yes. Could she pay her bills if she made $81 a week? Yes. So to make at least $80 a week, you want to make greater than or exactly equal to $80. So that is our first inequality. Then the second one, but she can work no more than 12 hours a week. So X is standing for hours for babysitting. Y is standing for hours of gardening. So the number of hours for babysitting plus the number of hours for gardening, she can work no more than 12 hours. So no more than, less than, or equal to 12. So now we've got our two systems. We need to make sure that they are put in Y equals mx plus b before we can start graphing them. So for this first one, we want to get rid of our 10x on both sides. So to pick this up and move it over, we've got to subtract 10x from both sides. So our 10x's go away. So we're left with 5y is less than or equal to, remember these do not combine, they're not like terms. Same variable to same power if you are allowed to combine them. This doesn't have an x, so we cannot combine them. So we just rewrite this as negative 10x, that's a positive 80, so plus 80. So negative 10x plus 80. Now to get y by itself, this is what operation? Multiplication. So to undo it, we need to do the opposite of multiplying. We need to divide. So divide this term by 5, the negative 10x by 5, and the 80 by 5. So then you can just use your calculator if you need to. So your 5's cancel. So you're left with y is greater than or equal to negative 10 divided by negative 5 gives you a positive 2. So we've got oh, we divided by a positive 5. I'm sorry. So negative 10 divided by positive 5 gives us a negative 2x. And then 80 divided by 5 gives us 16. So negative 2x plus 16. Okay, let's come over to this one. So we just need to get rid of this x. So we will subtract both sides by x. Cancels. So y is less than or equal to, again, these are not like terms, so just rewrite it, negative x plus 12. Okay, so let's identify our b and our m. So our b is 16 here. Our m, negative 2. How do you write that whole number as a fraction? Put it over a 1, and I'll put my negative down in the denominator. So 2 over a negative 1. Then over here, my b is 12, and my slope is negative 1. How do you write that as a fraction? Put it over a 1, and I'll put my negative down in the denominator. Now we need to decide how are we going to count our intervals here. So you kind of have to look ahead. Well, for our y-intercepts, we have to go as high as 16. So if I count by 2's, that will take us up to 20. So I'm going to count by 2's here. So 0, 2, 4, there's my 16, as tall as we need to get. But we'll put up to 20 up there. And then down along the bottom, because when we run, we're only running by a 1, we can just count by 1's down here. Okay, now we're ready to start graphing these. So this first one had a y-intercept of 16, a slope of 2 over negative 1. So we can't rise 2. Now notice this is counting by 2, so when you actually rise 1, you're actually rising 2. So we can't rise 2 and go 1 to the left because we're not talking about any negative values, so we don't need to worry about that. But we can go down 2, so down from 16 to 14, that's actually going down 2, and then 1 over to the right. So just continue that pattern. Down 2, 1 to the right. Down 2, 1 to the right. And this was greater than or equal to, so that gives us a solid line. And it is greater than, so we're going to shade everything above this line. So notice I'm going to get really close to this line here. And you'll see why in a second. So make sure your shading is really close to that line, so don't miss any areas here. Okay, then the second equation, our b is at 12. Now rising 1, so again, if we rise 1, then that's just halfway because 13 is really right here. And then running 1 to the left, but we don't have anything going on in the negative direction. So instead, we're going to go down 1, which will be right here in the middle of the 10 and 12. So that's down 1 at 11, and then 1 to the right. So right there in the middle. So down 1 now would be down to the 10 and over 1. Down 1 would now be at the 9, so in between the 8 and the 10, and over 1. Down 1 would be down to the 8 and over 1. It would share that point. Down 1 then would be down to the 7 over 1. Down 1 would be down to the 6 over 1. Down 1 would be at the 5, so in between the 4 and the 6 over 1, and just continue that. Okay, and then draw that line, and again, that will be a solid line as well. And this is less than this line. So less than this line would be everything down below, including right inside of here. So right in here is where that double shaded area is, this little triangular pocket here. So right in here is where your solutions would lie. So then it asks part C here, describe all the possible combination of hours that Charlene could work at each job. So you could pick any points that are within this area. So anything that you want would be good solutions. So for instance, if we picked, if we went over 6, up 4, that would be right there on that line, which also includes that point. Because when it's a solid line, a solution can be right there on that point. So we could technically list that as a point. So we could write six, 4 as a point. We could come over 8, over 8, up 2. That could be a point that you list. So any points that you list within this double shaded area is where your solutions are. Then list 2 possible combinations. Well, we could use these 2 combinations right here, and we could say 6, our x-axis is hours babysitting, our y-axis is hours gardening. So we could say 6 hours babysitting, 4 hours gardening. As one possible solution. And we could say 8 hours babysitting, 2 hours gardening. Okay, so now for my students, go ahead and practice C, the other side here on your own. Good luck. Get a hold of me if you need me.